Okay, in this video we're talking about Newton's second law of motion. Basically, Newton's second law can be summed up as this formula right here. Force, or F equals m times A. So F meaning is equal to the force. So that would be force, m is mass, and then you're multiplying that times A, which is acceleration. And so today in class, you guys did an excellent job of figuring out the relationship between these three things. And so that's basically what Newton's second law does, is describe the relationship between force, mass, and acceleration. And so we can use this formula to kind of solve for some of these things that go along with it. But sometimes it's hard to look at the definition, like this one down here, and figure out what those relationships are. A lot of times it's easier just to think of an actual example, kind of like you guys rolling the different objects today. You guys were able to figure out those relationships pretty easy. But if you are reading something like this, the acceleration of an object is directly proportional to the force acting on it. What does that mean? That means it has a direct relationship. So if one thing increases, the other one's going to increase. And so to kind of give you an example of that, if I have two golf balls here of equal mass, so you can see they're the same size or the same mass in this case, but if I apply different forces to it, so the first one I'm going to apply a 1 Newton, you can see the acceleration, see how fast it's moving. Second one I'm going to increase that force, so you can see it goes a lot faster, so 1 Newton compared to 5 Newtons. So all this means basically is that when when force, if it goes up, then acceleration goes up. If, let's say, force goes down, then acceleration is going to go down. So they're directly proportional to one another. On the other hand, let's look at Newton's second law with mass and acceleration. So I'll give you two examples here again. On this one we have a smaller object pushed at 1 Newton. So if we keep that force the same with our 1 Newton, but this is a bigger object, so now we've increased our mass, you can see acceleration goes down. And so in this case, if you increase mass, then acceleration goes down. So that's where we get an inversely proportional. So that means basically the opposites happen. If one goes up, the other one goes down. If mass goes down, so if we have a smaller object, like the first one here, then acceleration goes up, and that's if you keep the forces the same. So as long as force is the same, mass goes up, acceleration goes down. If mass goes down, acceleration goes up. One of the things that I noticed you guys were doing was kind of talking about mass and weight as the same thing. Well, they are a little bit different, and I kind of want to explain that really quick, what the difference is between those. So if we look at mass, the definition of mass is basically it includes, if you're looking at the mass of an object, it's everything that makes up that object. So how much matter is in that object. So if we looked at this astronaut here, everything inside that astronaut would be its mass. So that includes that guy's bones, his organs, everything that makes up his body would be the mass of that guy. Weight, on the other hand, is how much is basically a measurement of gravity and how much gravity is pulling on that object. So if we're standing on Earth and we have an astronaut here, he's going to weigh more on Earth because Earth is a bigger object than the moon. So if he goes to the moon, he's going to actually weigh less on the moon, but his mass is going to stay the same. So how much mass he has stays the same. So because gravity is pulling on that guy less, so if he jumped in there, he'd be able to jump a lot higher on the moon than he would on Earth. So to kind of show you another example here of that real quick, this is the same guy standing on different planets here, or in this case the moon or the sun, which are not planets. But his mass is 63.5 kilograms. And so the mass always stays the same. Remember, mass is how much stuff is inside of him. How much matter makes up that object. So in this case, it's 63.5 kilograms. Again, that's the SI units, which is roughly 140 pounds. Or weight-wise, it's equal to 140 pounds. Weight, since weight is a measure of gravity pulling down on you, remember gravity is a force, and we measure force in newtons. So you see weight is the person is 623 newtons, and that's on Earth, right? And if we look at it on the moon is a smaller object, so now his weight has went down. It's 103 newtons, or 23 pounds compared to 140 pounds. His weight on Jupiter's a lot bigger than Earth, so now his weight is 1,500 newtons roughly, and about 355 pounds. If we look at it on the sun, you would weigh, or this guy would weigh about 3,000 pounds. So depends on gravity to define weight, but you see mass always stays the same throughout, 63.5, because that's the amount of matter that object's made of doesn't change, but weight will. Okay, so just to kind of run through a couple of practice problems using Newton's second law formula of force, which is force equals mass times acceleration. This is the one I'm going to stick with. You guys can rearrange this in different ways like you did it in the activity today. I'd also want to show you guys this. So the easiest way to do this is probably just to memorize one of these formulas and then memorize this as well, the little circle helper outer thing. So basically force is equal to, force should be up here, is equal to mass times acceleration. We can use that to solve some things. So in this first question it says force would be, what force would be required to accelerate a 50 kilogram wolf at 5 meters per second squared. So remember, meters per second squared is acceleration, kilograms is mass in this case, and then force is going to be in newtons. So our answer, because we're looking for force, should be in newtons. So we'll just plug these things in. So in this case, we have 50 times 5 is going to give us 250 newtons. So that would be the answer for force in this case. So you would put F equals 250 newtons, and that would be your answer. Make sure that you include your units, otherwise it's just 250, and that could be 250 of anything. So make sure you include your units and show your work, otherwise you're not going to get the points correct. The next one, a net force of 15 newtons is exerted on an encyclopedia to cause it to accelerate at a rate of 5 meters per second. Determine the mass of the encyclopedia. So now we're trying to find mass, so we can write our formula out. F equals mass times acceleration. We're trying to find mass, so you're going to leave that one just as m. Force is 15, acceleration is 5 times m equals. So now we can use this up here. If we're trying to find m, remember you cover up the m and then it tells you what to do. Force divided by acceleration. So 15 divided by 5 gives us 3 for our mass. So you can write it out again, m equals 3 kilograms. So that's how you'd solve for m. Do it the same way for acceleration. All right, now the last thing I want you guys to do is to solve a practice problem and be ready for class next time. Make sure you do the summary and everything. This is the last question for you guys. Hopefully this was helpful. I'll see you guys in class. Bye.